In this video, I will show how to process patch test data collected using a multi-beam echo sounder system mounted on a drone. For processing, I will use BeamworX software suite. As a data example, I will use this dataset collected over Titurga Lake, close to SPH engineering office. After 2 videos, you will get to the data you see here on the screen now. The data that I will use can be downloaded here from attachments. You need to download this archive that contains the raw svlog data. svlog is a proprietary format of the multi-beam system manufacturer Cerulean. So let's start. First, I will explain what kind of data is required for the patch test. Take a look at this graphic from the AutoPatch manual that shows pairs of survey lines. For our system, you need to collect data over at least 2 lines. Both lines need to be flown in 2 directions, there and back again over the same line. The important thing is that there has to be a 50% overlap for the multi-beam data for those 2 sets of lines. It is recommended to place those lines over some constant slope with the deepest part at the end. So how can you calculate the distance between those 2 lines to achieve a 50% overlap? Here you can use an Excel file for the multi-beam calculator. First enter the estimated smallest depth in the patch test area, which in this case is 6 meters. For AutoPatch test, the overlap should be 50% or more. And this will give you the necessary distance between the survey lines. So again, 1 line in 2 directions, second line in 2 directions, and at least 50% overlap between those lines. That is how you collect data suitable for a patch test. Let's start AutoPatch utility. As I said before, it is a part of BeamworX software suite. Create a new project. We need to add our multi-beam files here. In the current BeamworX version, it is already possible to import svlog files directly, without any additional converters. Next, here select the option Create Artificial Profile for Sound Velocity from Raw Multi-Beam Records. Of course, if you have a sound velocity profile, you can use that instead. Next, select the folder where to place the AutoPatch project. And finish. You will see 3 sections or 3 zones on the screen. The first zone is the chart view. Here you will see the map, and it is very convenient because you can check that your data is in the right place. Also, here you will see the tracks of your survey lines. Here I imported data for the entire survey, not only for the patch test. So we will see multiple lines, but for the patch test we need only 2 pairs. 1 set of 2 lines in opposite directions, and here as well. The second zone is the list of the data files with the possible combinations of usable offsets. R means that the file can be used for the roll angle offset calculation, P for the pitch, H for heading. So we need to have at least one pitch roll heading combination to calculate all three required offsets. And here you will see the representation of the data used for the roll pitch heading offset calculation. In some cases, if the lines are too close to each other, AutoPatch can automatically merge lines, which is not desirable. If that happens, you will need to close AutoPatch and edit one option in the project file. This one. Allow merging split files. You change it to false and start AutoPatch again. So if you see your data in the right place on the map, if you see that AutoPatch found enough combinations, you can then click the icon AutoPatch. Here we have only two possible combinations, and AutoPatch calculated the recommended offset angles. Click Apply, and we will see here on the right side that the data is better aligned now. If you are satisfied with the results, actually that is all. You can export the report. And here you should find the calculated advised mounting angles that you can use for your survey. In the best case scenario, that is all. You can also see the angles we just calculated in the vessel configuration. That vessel configuration is generated automatically from your data files, and here you will also see the calculated offsets for roll, pitch and heading. That is all in this video.